So this is basic offensive applications of MOF files in WMI scripting. I am Sam Ruthenberg. This is Devon Bordonaro and Connor Gephart. We're all students at Towson University. Represent. I see a little row. And we're all, Devon and I are seniors. Connor's a sophomore. We're all comp sci majors studying cybersecurity, and we kind of did this project, a little side thing, be more familiar with like some newer applications of Windows, and try to test out some new offensive applications of a really powerful tool called WMI, which we hope to like kind of introduce you guys to and see if you guys can come up with your own MOF files to hack your friends. So, but first, like, what is the Windows Management Instrumentation, or WMI? You all have it in your Windows computers at home. It's how a lot of the Windows operating system is going to be working in the background. One of the most common applications of something like this, and most of you have probably seen, is when your battery gets kind of low, like 15%, you see a little pop-up show up. That's kind of like what WMI is doing. It's monitoring the Windows system in the background, and it's going to check things like hardware. So like what what's CPU usage, what's my battery percentage, software, so like what processes are running, how I should handle those processes running, how I should handle like hardware changes in the state. So it's really just Windows monitoring itself and being able to respond to certain events happening on the computer. And then, so like, what is the WMI database? It's really intuitive and great. As you can see, the little photo, that is the WMI database. Really great to view. You can really understand what's going on there, right? Like, right? No, you can't. It's 5 files you can't open with anything like pre-installed on Windows. Like, you need outside software not installed to just view anything going on. So as a normal user, or even as a advanced user, it's very hard to understand and know what WMI objects are saved in your operating system. So, but like, what is in that database? There are namespaces and subnamespaces. So we use a lot of the ones in the root. So it's the root namespace, and then underneath that we're in the CMV2 subnamespace. And then inside of that there are classes. So we have like event filters and consumers. These are going to be like kind of like your function calls in a normal program. So you're going to be able to use these functions in a namespace to like create new events that you can use to personalize your computer, or in our case, do some malicious activity.
All right, so obviously it's not the most intuitive of programs that Windows has ever created. So to interact with it, there's a couple different ways. One of them is through the WMIC command from the command line. You can specify stuff like in this example, we have our namespace is root/subscription. We're looking for things, event filters, where their names are start filter process, and we're trying to delete that namespace. So this would remove an object from the database. You could add, you can list all the ones that are in a certain namespace. You can really do whatever you want with these commands, but they're kind of clunky. So a better way to do it would be with a MOF file, or managed object format file. So it's a file specifically made to interact with the WMI database. It's basically a text file form of the WMIC command, but a little better. It's more programming oriented, so it's easier to use, I'd say. You can also insert different scripts in it, such written in languages like C, C#, Java, Python, etc. So you store these files wherever you want in the system, use the command mofcomp to compile them, but like, there's a big distinction here that like MOF files don't run like normal programs. They just kind of like, they add stuff to the database whenever it's run, and then the database handles anything that happens when those objects are needed. So like, these files just kind of exist, but they don't need to run anything. They're not a process that's running after they're compiled. So in these files you have events or consumers, which Devon's about to tell you about right now.
So you have events, and events, you kind of heard of them before. It's going to be anything that happens on the system, pretty much. So you have tons of events. It could be things like the user runs a process, or the user logs in, or a file gets accessed, or the user Bob fails to log in because he gets his password wrong. Your battery hits 15%, like we said. So there's a lot of events, and these event filters are going to keep track of that and kind of log when it happens. And when it does happen, we have things called consumers that will tell it what to do. Right here we have an example of an event filter that we used. This is just a pretty basic one. It's going to check the process start trace. for any process named or that contains procexp. So sysinternals process explorer, what we're using here. Yeah. And here's the consumer. So the consumer is going to be how the system responds to that event. So when the event happens, it's going to say, all right, do this. So this is one that we use. This is just saying when procexp is run, kill it. We used a command line template. There's ActiveScript template. There's log templates. There's a lot of different templates for various usages, but we used a command line shell. So that is what we used. The part that ties it all together is going to be a filter to consumer binding, and this is just to tie the event to the consumer so that it knows when this event occurs, do this. You can have multiple consumers for one event, so when one event occurs, you could do many, many different consumers. But on to some more fun stuff. We have a demo to show you kind of how you can use these tools for, useful things, but also malicious things as well. So let's get into it. I'm going to put this here. All right. So we talked about how WMIC is the command line tool to use the database and kind of view it and edit it, but it's not very intuitive. You have to know a lot of command line, and it's kind of a little clunky. So they have a GUI-based application called WMI Explorer, and it's used to administer the database. As you can see, you have your namespaces that we talked about, and then you have your sub namespaces, and then you have your classes that we talked about, instances, and then the content of that instance. It's still not very user-friendly. You have to know what you're looking for if you want to use this. It's kind of like registry. You don't want to pick around in here. You might break some stuff. Also, it's not installed by default on Windows, so again, if you don't have this, it's not going to be very useful for you. So one of the uses we talked about would be logging. That'd be the biggest use people would use it for. So a user opens a file, you want to log that, you want to see when someone's opening a file. So one of the examples we had, which I'm going to show you really fast, this is a pretty basic MOF file. It's kind of long, but it's a little clunky. So this is basically saying, actually I'm going to go down here to the event filter. This is the event filter, almost the exact same as one we had in the slides, except this one's using PowerShell. So when PowerShell is run, it's going to log that, and then the consumer is saying up here, again, it's a little long, but the consumer is saying when PowerShell is run, do this. So this is making a file called log process, and it's going to write to that file saying PowerShell was started at this time. It has this process ID, and this is the parent process ID. And then it also does the exact same thing when it stops. So you know when a user is starting the process, ending the process. So you want to know maybe your employee is using PowerShell, they shouldn't be using it. You want to know when they used it, when they stopped, what they did. We didn't track it by username, but you could do that. So just to show how that's working, I'm going to go ahead and compile that. All right, so that's been compiled. When I go ahead and open up PowerShell, so you're going to see it's running now. A little log process text file was created, and it's going to say when the process was started with the ID and the parent ID. Now if I go ahead and I close it, I'm going to also have to close this because Notepad. And it's going to say when it was stopped. And parent PID is 0 because the process is dead, there is no parent. But so this is kind of just how you would use it in a non-malicious sense to log and see what's going on in the system. But we also have some more malicious ways you can use it, and Sam's going to talk about that.
So how many of you guys have been in the scenario? You're hacking your friend and you use privilege escalation and you get system, and then you're like, you know what? This guy keeps killing my system shell, and I don't like that. I don't want him to keep killing my shells. It happens to me too, everyone, but don't worry, there's a way to solve it. It's a problem that plagues a nation. So I will open up this one. So this was just called ptest, and this is a very simple MOF file as well. So it's just two parts because you want the shell to start when the user logs on because, when your friends log on, you always want to have system on all the time. So whenever they're going to log on, it will then the event filter is going to check the process stop, or it's going to check the instant creation event of a 132 logon session. So when that instance happens, it will then trigger the consumer. That's going to then call your shell program that you just hid somewhere in the file system. And because it's Windows, they're never going to find that in the file system. You just bury that thing deep. And because it's WMI, even if you hide it somewhere running a system, WMI will always be system. So any process that WMI is going to call will have system level privileges, which we can show. So if we just MOF and spell it right, that will then store it as well. And because these MOF files aren't a process, they're part of the operating system itself, when the computer restarts or isn't turned on for a week, the process will always be running because it's not really a process. It's more part of the operating system at this point. So, they're not going to see a process that's calling back, that's going to start the shell up when it's logged on. It's not going to be showing up in their programs aren't start file because it's not a process. It's more of the operating system itself that's doing these things. So now, when I log off, my little friendly shell program is going to be called, and then on the command and control module on the Kali system, you're going to now have a shell that's calling out to you, and you can just restart your handler, and you'll be able to get right in. You do it.
Oh my god.
I know. Oh my god. They have to be able to log in first. That's key. So now, after I logged in, you'll see a friendly little program called free RAM running. I'll give you a hint, it's not actually free RAM running. Right there. And now, as you see, if I try to kill this process tree, I can't. I don't have access. That's higher privilege than I am right now, because it's just running a system because WMI called that process. So then on a Kali system, I know, let's see if I can do that.
These passwords are the same, so.
Nice. Did it that time. Did it that time. All I have to do is I'm going to restart my handler. It's then going to connect to that. I now have a shell. So in sessions, there you go. I am the authority system. I can now go into this on a reverse TCP and interpreter. I can do whatever I want. I run this system at this point. So it's just a new way that you can really set persistence on a system in an inventive way that a user might not be looking for, because it's not going to be a normal process and process start. And even more fun if they just, be admin. In case your user gets smart and they realize that free RAM might not actually be free RAM, somehow, we don't know how, and they kill the process, it just comes right back. So this kind of persistence will just always be there. There's going to be 2 on. And as a normal user, unless you go into MOF and you remove that file or you find the file that's giving that persistence, you're not going to be able to remove this off the system. So it's a new way you can get persistence on all your friends, so when they log in, you can be system and just do whatever you want. And Connor will show you our true goal.
Okay, so yeah, you can hack your friends and get persistence, whatever. But I really just want to make fun of them, be like, ha, hacked you, elite skills. So when we were first assigned, not assigned, but when we first started this, a professor asked us, he was like, hey, you guys should figure out a way so that whenever Process Explorer is run, it immediately quits, and then it puts up a picture of the Marshmallow Man from Ghostbusters, and it says, there is no Process Explorer, only Zool. And we were like, yo, that sounds awesome. I would love to do that to my friends. But it turns out it's very, very difficult to be overt using the WMI database because, as Sam said, it all runs a system. So we'd start the process with the picture popping up, and it would be in the background because it's running a system. The user would never see it. So we were like, well, this is kind of dumb. Sure, it works, but you can't see it. It's not cool. So we came up with a better solution, which I will demonstrate currently, and it's a surprise. So 2 moments for me to compile this file. So we have this wonderful fundeath.mof file. So now I'm going to just try and run Process Explorer because I want to see what processes are running. Oh no, it immediately died. Whoa, that's not supposed to. My bad. Really? Nothing ever works the first time, I guess. Yeah. That's a bummer. The volume is up.
This is the HDMI.
So it turns out that the HDMI cord is accepting the volume, but there is no speaker attached to this projector. So we can demonstrate the meme
We could unplug the HDMI.
by unplugging the HDMI, and you won't be able to see it, but you've seen it kills Process Explorer. And then, after it because it says system, the user's like, please make this noise stop. It's running 2 instances. Help. I'm going to shut it down. It just keeps going and going until until the computer is completely shut off. The user's like, oh no, help. And this, again, will still be there if they try and run Process Explorer when they turn it back on. Tough luck. You get more Rick Astley, never going to give you up. We had a great time doing this project. It was a lot of fun. A lot of hard coding, many issues as you can see. But it was really a great learning experience, and I'm really happy that we did it. And now you all know how to meme your friends with never gonna give you up all the time. Thank you very much.
Any questions?
Yeah. Yes.